Section 4, the history of astronomy. Of all the phenomena of nature, the celestial appearances are, by their greatest and beauty, the most universal objects of the curiosity of mankind. Ancient physics, of the expense of the institutions for the education of youth. The great phenomena of nature, the revolutions of the heavenly bodies, eclipses, comets, thunder, lightning, and other extraordinary meteors, the generation, the life, growth, and dissolution of plants and animals, are objects which, as they necessarily excite the wonder, so they naturally call for the curiosity of mankind to inquire into their causes. In LRBL, Smith says, the more lively and striking the impression is which any phenomenon makes on the mind, the greater curiosity does it excite to know its causes, though perhaps the phenomenon may not be intrinsically half so grand of important as another less striking. Thus it is we have a greater curiosity to pry into the cause of thunder and lightning and of the celestial motions than of gravity, because these naturally make a greater impression on us. Below, and the use of the circle in early astronomical theory. Those who surveyed the heavens with the most careless attention necessarily distinguished in them three different sorts of objects: the sun, the moon, and the stars. These last appearing always in the same situation and at the same distance with regard to one another, and seeming to revolve every day around the earth in parallel circles. Below, and the use of the circle in early astronomical theories, which widen gradually from the poles to the equator. For technical terms employed in the ancient astronomy, see the editor's introduction, page 15 to 16, were naturally thought to have all the marks of being fixed, like so many gems, in the concave side of the firmament, and of being carried round by the diurnal revolutions of that solid body. For the azure sky, in which the stars seemed to float, was readily apprehended, upon account of the uniformity of their apparent motions, to be a solid body, the roof or outer wall of the universe, to whose inside all those little sparkling objects were attached. C'est ça que j'ai traduit. The sun and moon, often changing their distance and situation in regard to the other heavenly bodies, could not be apprehended to be attached to the same sphere with them. They assigned, therefore, to each of them a sphere of its own. That is, supposed each of them to be attached to the concave side of a solid and transparent body, by whose revolutions they were carried round the earth. There was not, indeed, in this case, the same ground for the supposition of such a sphere as in that of the fixed stars. For neither the sun nor the moon appear to keep always at the same distance with regard to any one of the other heavenly bodies. But as the motion of the stars had been accounted for by a hypothesis of this kind, it rendered the theory of the heavens more uniform, to account for that of the sun and moon is in the same manner. The sphere of the sun they placed above that of the moon, as the moon was evidently seen in eclipses to pass betwixt the sun and the earth. Each of them was supposed to revolve by a motion of its own, and at the same time to be affected by the motion of the fixed stars. Thus the sun was carried round from east to west by the communicated movement of this outer sphere, which produced by the communicated movement of this outer sphere, which produced his diurnal revolutions and the vicissitudes of day and night. But at the same time he had a motion of his own, contrary to this, from west to east, which occasioned his annual revolution and the continual shifting of his place with regard to the fixed stars. This motion was more easy, they thought, when carried on edgeways, and not in direct opposition to the motion of the outer sphere, which occasioned the inclination of the axis of the sphere of the sun, so that of the sphere of the fixed stars. This again produced the obliquity of the ecliptic and the consequent changes of the seasons. The moon, being placed below the sphere of the sun, had both a shorter course to finish, and was less obstructed by the contrary movement of the sphere of the fixed stars, from which she was farther removed. She finished her period, therefore, in a shorter time, and required but a month, instead of a year, to complete it. The stars, when more attentively surveyed, were some of them observed to be less constant and uniform in their motions than the rest, and to change their situations with regard to the other heavenly bodies, moving generally eastwards, yet appearing sometimes to stand still, and sometimes even to move westwards. These, to the number of 5, were distinguished by the name of planets, are wandering stars and marked with the particular appellations of Saturn, Jupiter, Mars, Venus, and Mercury. As, like the Sun and Moon, they seem to accompany the motion of the fixed stars from east to west, but at the same time to have a motion of their own, which is generally from west to east. They were each of them, as well as those two great lamps of heaven, apprehended to be attached to the inside of a solid concave and transparent sphere, which had a revolution of its own, that was almost directly contrary to the revolution of the outer heaven, but which at the same time was hurried along by the superior violence and rapidity of these last. This is the system of concentric spheres, the first regular system of astronomy which the world beheld, as it was taught in the Italian school. No objection can be raised to this account of the science of the Italian school, since it is not unlike what classical scholars would have said until quite recent times. Today, however, it seems by no means certain that the Pythagoreans deserve the place in the early history of mathematics and astronomy which tradition has given them. It is safer to regard Eudoxus as the originator of the system of concentric spheres. Before Aristotle and his two contemporary philosophers, Eudoxus and Callippus, on Eudoxus and Callippus, Allen articled Plato. As Smith says in paragraph 7 below, Eudoxus was the friend and auditor of Plato. We learn on good authority that he propounded his system in answer to a problem posed by Plato. Our knowledge of the system comes from Aristotle Metaphysics and the commentary of Simplicius on Aristotle De Caelo. Smith was obviously acquainted with the former, probably with the latter also. Had given it all the perfection which it is capable of receiving, though rude and inartificial. Far from being rude and inartificial, the system of Eudoxus is a remarkable piece of mathematical analysis, virtually a geometrical equivalent of Joseph Fourier's algebraic resolution of a complex curvilinear motion into simpler components. It is capable of connecting together in the imagination the grandest and the most seemingly disjointed appearances in the heavens. The motions of the most remarkable objects in the celestial regions, the sun, the moon, and the fixed stars, are sufficiently connected with one another by this hypothesis. The eclipses of these two great luminaries are, though not so easily calculated, as easily explained, upon this ancient as upon the modern system. When these early philosophers explained to their disciples the very simple causes of those dreadful phenomena, it was under the seal of the most sacred secrecy, that they might avoid the fury of the people, and not incur the imputation of impiety, when they thus took from the gods the direction of those events, which were reprehended to be the most terrible tokens of their impending vengeance. The obliquity of the ecliptic, the consequent changes of the seasons, the vicissitudes of day and night, and the different lengths of both days and nights in the different seasons correspond to, pretty exactly, with this ancient doctrine. As if there had been no other bodies discoverable in the heavens besides the sun, the moon, and the fixed stars, this old hypothesis might have stood the examination of all ages, and have come down triumphant to the remotest posterity. If it gained the belief of mankind by its plausibility, it attracted their wonder and admiration. Sentiments that still more confirmed their belief by the novelty and beauty of that view of nature which it presented to the imagination. Before this system was taught in the world, the earth was regarded as what it appears to the eye, a vast, rough, and irregular plain, the basis and foundation of the universe, surrounded on all sides by the ocean, and whose roots extended themselves through the whole of that infinite depth which is below it. The sky was considered as a solid hemisphere, which covered the earth and united with the ocean at the extremity of the horizon. The sun, the moon, and all the heavenly bodies rose out of the eastern, climbed up the convex side of the heavens, and descended again into the western ocean, and from thence, by some subterraneous passages, returned to their first chambers in the east. Nor was this notion confined to the people or to the poets who painted the opinions of the people. It was held by Xenophanes, the founder of the Eleatic philosophy, after that of the Ionian and Italian schools, the earliest that appeared in Greece. Thales of Miletus, too, who, according to Aristotle, represented the earth as floating upon an immense ocean of water, may have been nearly of the same opinion. Notwithstanding what we are told by Plutarch and Apuleius concerning his astronomical discoveries, all of which must plainly have been of a much later date, to those who had no other idea of nature besides what they derived from so confused an account of things, how agreeable must that system have appeared which represented the earth as distinguished into land and water, self-balanced and suspended in the centre of the universe, surrounded by the elements of air and ether, and covered by 8 polished and crystalline spheres, each of which was distinguished by one of or more beautiful and luminous bodies, and all of which revolved round their common centre by varied but by equable and proportionable motions. It seems to have been the beauty of this system that gave Plato the notion of something like an harmonic proportion to be discovered in the motions and distances of the heavenly bodies, and which suggested to the earlier Pythagoreans the celebrated fancy of the music of the spheres. A wild and romantic idea, yet such as does not ill correspond with that admiration which so beautiful a system, recommended too by the graces of novelty, is apt to inspire. Whatever are the defects which this account of things labours under, they are such as to the first observers of the heavens could not readily occur. If all the motions of the 5 planets cannot, the greater part of them may, be easily connected by it. They and all their motions are the least remarkable objects in the heavens. The greater part of mankind take no notice of them at all, and a system whose only defect lies in the account which it gives of them cannot thereby be much disgraced in their opinion. If some of the appearances too of the sun and moon, the sometimes accelerated and again retarded motions of those luminaries but ill correspond with it, these two are such as cannot be discovered but by the most attentive observation, and such therefore as we cannot wonder that the imaginations of the first inquirers should slur over, if one may say so, and take little notice of. It was, however, to remedy those defects that Eudoxus, the friend and auditor of Plato, found it necessary to increase the number of the celestial spheres. The phrase is incorrect if Eudoxus was the originator of the spheres. Each planet is sometimes observed to advance forward in that eastward course which is peculiar to itself, sometimes to retire backwards, and sometimes again to stand still. To suppose that the sphere of the planet should by its own motion, if one may say so, sometimes whirl forwards, sometimes whirl backwards, and sometimes do neither the one nor the other, is contrary to all the natural propensities of the imagination, which accompanies with ease and delight an irregular and orderly motion, but feels itself perpetually stopped and interrupted when it endeavours to attend to one so desultory and uncertain. It would pursue, naturally and of its own accord, the direct or progressive movement of the sphere, but is every now and then shocked, if one may say so, and turned violently out of its natural career by the retrograde and stationary appearances of the planet, betwixt which and its more usual motion the fancy feels a want of connection, a gap or interval, which it cannot fill up, but by supposing some chain of intermediate events to join them. The account that follows is based on Aristotle's metaphysics. Spheres of the planets of Sun and Moon, system of Callippus. The hypothesis of a number of other spheres revolving in the heavens, besides those in which the luminous bodies themselves were fixed, was the chain with which Eudoxus endeavored to supply it. He bestowed 4 of these spheres upon each of the 5 planets, one in which the luminous body itself revolved, and 3 others above it. Each of these had a regular and constant, but a peculiar movement of its own, which it communicated to what was properly the sphere of the planet, and thus occasioned that diversity of motions observable in those bodies. One of these spheres, for example, had an oscillatory motion. Smith seems to have misunderstood the nature of the oscillation, since the currently accepted characteristics, constant and equable, contradict it. He may have failed to recognize that the oscillation is only relative to the observer. like the circular pendulum of a watch, as when you turn round a watch, like a sphere upon its axis, the pendulum will, while turned round along with it, still continue to oscillate and communicate to whatever body is comprehended within it, both its own oscillations and the circular motion of the watch. So this oscillating sphere, being itself turned round by the motion of the sphere above it, communicated to the sphere below it, that circular, as well as its own oscillatory motion, produced by the one the daily revolutions, by the other the direct stationary and retrograde appearances of the planet, which derived from a third sphere that revolution by which it performed its annual period. The motions of all these spheres were in themselves constant and equable, such as the imagination could easily attend to and pursue, and which connected together that otherwise incoherent diversity of movements observable in the sphere of the planet. The motions of the sun and moon being more regular than those of the 5 planets, by assigning 3 spheres to each of them, Eudoxus imagined he could connect together all of the diversity of movements discoverable in either. The motion of the fixed stars being perfectly regular, one sphere he judged sufficient for them all, so that, according to this account, the whole number of celestial spheres amounted to 27. Callippus, though somewhat younger, the contemporary of Eudoxus, found that even this number was not enough to connect together the vast variety of movements which discovered in those bodies, and therefore increased it to 34. Aristotle said that Callippus found it necessary, in order to explain the phenomena, to assign 2 additional spheres each to the sun and moon, and one each to Mars, Venus, and Mercury. Thus his total was 27 plus 4 plus 3. Aristotle, upon a yet more attentive observation, found that even all these spheres would not be sufficient, and therefore added 22 more, which increased their number to 56. This elaboration of the system is described in Aristotle's De Caelo. See the editor's introduction, page 17. Later observers discovered still new motions and new inequalities in the heavens. New spheres were therefore still to be added to the system, and some of them to be placed even above that of the fixed stars. So that in the 16th century, when Fracustorio, that is to say Girolamo Fracustoro, an outstanding figure linking the humanistic literary renaissance with the so-called scientific revolution. The theory referred to by Smith was set out in Fracastoro's Homocentrica. Smith, with the eloquence of Plato and Aristotle, and with the regularity and harmony of their system, in itself perfectly beautiful, though it corresponds but inaccurately with the phenomena, endeavored to revive this ancient astronomy, which had long given place to that of Ptolemy and Hipparchus. Hipparchus, of course, preceded Ptolemy, who is one of the prime sources for our information about him. He found it necessary to multiply the number of celestial spheres to 72. Neither were all these enough. The system had now become as intricate and complex as those appearances themselves, which it had been invented to render. Imagination, therefore, found itself but little relieved from that embarrassment into which those appearances had thrown it by so perplexed an account of things. Another system, for this reason, not long after the days of Aristotle, was invented by Apollonius of Perga, the great geometer. His theory of planetary motion is known from Ptolemy's Almagest, which was afterwards perfected by Hipparchus and has since been delivered down to us by Ptolemy, the more artificial system of eccentric spheres and epicycles. In this system, they first distinguished betwixt the real and apparent motion of the heavenly bodies. These, they observed, upon account of their immense distance, must necessarily appear to revolve in circles concentric with the globe of the earth, and with one another, but that we cannot, therefore, be certain that they really revolve in such circles, since, though they did not, they would still have the same appearance. By supposing, therefore, that the sun and the other planets revolved in circles, whose centers were very distant from the center of the earth, that consequently, in the progress of their revolution, they must sometimes approach nearer and sometimes recede further from it, and must therefore to its inhabitants appear to move faster in the one case and slower in the other. Those philosophers imagined they could account for the apparently unequal velocities of all those bodies. come it is so hard to be the way you are? How come it is so hard to be the way you are? C'était quoi déjà? Ouais. By supposing that in the solidity of the sphere of each of the 5 planets there was formed another little sphere, called an epicycle, which revolves round its own centre, at the same time that it was carried round the centre of the earth by the revolution of the great sphere, betwixt whose concave and convex sides it was enclosed, in the same manner as we might suppose a little wheel enclosed within the outer circle of a great wheel, and which whirled about several times upon its own axis, while its centre was carried round the axis of the great wheel, they imagined they could account for the retrograde and stationary appearances of those most irregular objects in the heavens. The planet, they supposed, was attached to the circumference and whirled round the centre of this little sphere. The system of Ptolemy took no account of spheres. These were later introduced into it by the Muslim astronomers under the influence of Aristotelian physics. At the same time that it was carried round the earth by the movement of the great sphere, the revolution of this little sphere, or epicycle, was such that the planet, when in the upper part of it, that is, when furthest off and least sensible to the eye, was carried round in the same direction with the centre of the epicycle, or with the sphere in which the epicycle was enclosed. But when in the lower part, that is, when nearest and most sensible to the eye, it was carried round in a direction contrary to that of the centre of the epicycle. In the same manner as every point in the upper part of the outer circle of a coach wheel revolves forward in the same direction with the axis, while every point in the lower part revolves backwards in the contrary direction to the axis. The motions of the planet, therefore, surveyed from the earth appeared direct, when in the upper part of the epicycle and retrograde, when in the lower. When again it either descended from the upper part to the lower, or ascended from the lower to the upper, it necessarily appeared stationary. J'en serai à la page 61.